So here's our lab report for thin optical lenses part 2, lab number 4. So the first step of the procedure asks us to set up similar to what we had done last time, except this time we're going to use two 127 millimeter lenses with still an arrow and a yellow diffusing grating at the beginning and a nice target here at the end for us to see. So the first step, like I said, we're just using two 127 millimeter lenses. The target object here at the beginning is placed at 0. The first lens is placed at 200 millimeters. The measurement on the bench was taken into account your suggestion of the lenses being placed slightly farther back in order to incorporate the spacing between the actual lens and the holder. So it's actually placed at about 206. And then the second lens is placed here at 460. And we can see right here on our final image of the target that the image is inverted. And it's right in there.
Alright, so this is part 2 of the thin spherical lenses lab 2. Once again, just like in part 1, we have our object set at 0 with our yellow filter, and then we're asked to set the first lens 100 millimeters away from our object. We set it at 106 to account for the lens differential. We were once again asked to place the second lens 254 millimeters away from the first lens, and then to focus our image. And if you come and look at our image, we can prove that it is the same size as the actual, as the object, and the magnification is -1 because it's inverted.
So for the last step of this lab, number 3, we were asked to go ahead and set up the first lens at 300 millimeters distance from our object. So as before, we took into account the lens length between the holder and the lens, set it at 306, and then the other one needed to be 254 millimeters away from the first lens again. So this time we're here at 560. If you go ahead and place the target here on the track and go try and find an image, you cannot, and there is no image there. As stated in the procedure, we can go ahead and take a look down the track, and it's a little too hard to get on camera, but if you were here you could see it. There's a very intense inverted image right within the lens, the second lens.
Alright, so the reason why we don't end up getting an image to focus from behind the second lens is because the length or the distance between the object and the first lens is greater than 2 focal lengths, which makes the image virtual. The real image would actually be somewhere in between the 2 lenses, but we are not able to see that.